Hello, welcome to this second tutorial. The topic we're going to talk about today is sharing, continuing our theme of everything I need to know about Rust I learned in kindergarten, right? And in particular, what we want to do is address this problem that we hit at the end of the last tutorial. If you recall, we had this shared buffer, or this string buffer that we called name, and we were trying to call a function twice, and the first time we call it, we gave ownership of our buffer, but then we were in trouble because we didn't have ownership anymore when we wanted to call it the second time. And one solution we saw is that we could clone this buffer the first time, but that seems a little bit expensive. We're copying the string, which we don't really need to do. So what we're going to learn today is I would say is the much more idiomatic solution here, which is to share the string between the two functions. Now, if we go back to our kind of real life analogy, right, this is actually, again, a pretty normal thing, right? So if I have a book and I hand it to you, it might be that I'm giving it to you as a present forever, but usually what's happening is that I'm just saying, why don't you read this book? I think you might like it. And when you've finished with it, you give it back to me, right? So kind of I say, here you go, Principles of Compiler Design. Check out chapter 13, or I don't even know if there are 13 chapters. Check out chapter 2. It's really good. Then you say, very interesting. I liked it. And you give it back. That's how data structures work in Rust too, right? Is a very common scenario that we want to say, here's a string, I'd like you to print it on the screen, and when you're finished using it, I might do other things with it. Right? Okay, so here we see a similar code snippet to the one we saw in the ownership tutorial, but this time we're going to use borrowing to avoid copying the data. Right? So we're going to call helper twice, but we're not going to copy the data the second time. How does it work? It starts off just the same, that I say let name equals format bang, and that's going to allocate me a string buffer represented by this book. But what happens next is different. What I'm doing here with this ampersand name is I'm actually borrowing the variable name to create a reference, which is stored in the variable r. Okay? And I'm symbolizing that by shrinking the book. So r now is a reference to this string name, and the variable name actually owns the string. And when I call helper, you see that helper no longer expects to take ownership of a string. Instead, its argument type is ampersand string. That means helper is saying, give me a reference to a string called name. Right? And this string could be owned by either by main or by someone else up the stack. So that means that when helper runs, it's just going to have this reference pointing to the name which is owned by main. Right? So now helper will execute, it'll read this string through the reference, and when helper returns, no memory gets freed here because helper didn't own the string, helper just had a reference to the string. So it was just borrowing the string. And now we get back here and you see we can call helper again, and we can give the same shared reference, right? And that's no problem. That's because shared references like R are actually copy types. They can be used as many times as you want. Essentially, once you've started sharing access to a string, that means you can make any number of references to that same string, right? Now, eventually, we're going to finish. After this point, when we reach the brace, now this reference R goes out of scope, which means that we stop borrowing string because we're not using this reference anymore. And now, at this point, when main returns, all the data that main owns is going to get freed, which includes the string. Because basically here, whereas before we gave ownership of the string to helper, and then helper freed it, this time we kept ownership within the main function the whole time. Now, the references are really cool because they let you share data and have lots of different shared references to the same data. However, there is a kind of catch. While this data is shared and borrowed, it is also, generally speaking, immutable. So if you have a lot of people reading from the same data structure, that means that none of them can be writing to it. Right? So for example, helper function, this is the helper function we had. All that it did was print to the screen, and that's okay because it's just reading from the string. Perfectly good. However, if the helper function were trying to call this push method, you might recall we saw that last time, push adds a character onto a string, growing the buffer. That's a mutation. This would actually get a compilation error. We would see something like can't borrow immutable borrowed content. Right? Now, I'm actually simplifying here. Shared data is not always immutable. what it is that's the default, and it's kind of the best way to handle it. There are types which enable mutation in shared data, but those types have to have some kind of API that makes it safe to do so. So here's an example: a mutex, or a lock, that would allow you to share data between threads, but it wouldn't be safe for all of those threads to go mutating or reading from that data. They have to be in order, right? So the lock API kind of allows you to mutate that data, but only if you have the lock, so that you have an ordering. And we have similar APIs for other scenarios, so it doesn't always involve threads, but that's a very natural one. Now, what I'd like to do is take these examples, and I'm going to go over to the Play website and just do some interactive code editing that will give you a feeling for what I'm talking about. All right, so here we are at Play, and this is the example we ended with our ownership tutorial with. If you recall, we have a name, and we're trying to call helper twice, and we're getting this error, use of move value name. And the reason is we're giving ownership of the name here in the first line, as it says right here, value moved here. But then when we try to access it again, we've already given ownership away, so we're trying to use something we don't have anymore, and that's not allowed. So we said we can solve this by using borrowing, and in particular, shared borrows and shared references. All right, so here when I make the first step is I have to change helper so that instead of saying I need to own a string, helper just says I need to borrow a string from you for you to call me, right? And in terms of Rust, what that means is instead of taking a string as argument, we're going to take a reference to a string. But if I just compile this, you'll see I get errors over here at the call sites saying mismatched types. The idea is both the caller and the callee have to agree about who owns what and who's borrowing what. Right? So right here, when we say helper name, the main is sort of trying to give ownership to helper, and helper doesn't want to take it. That's the intuitive way to look at it. So we have to change to lend out name, right? And now main is creating a reference and giving the reference to helper, and helper is happy to accept the reference and do its job. And you see that now our code compiles because we can lend out the same value multiple times, and we retain ownership the entire time. Now what we saw is that this and name is really just an expression, right? So we might make a variable like so, and now I'm creating a reference, I'm borrowing name, making a reference and storing it in R, and I can use this R as many times as I want, right? So the type of this is ampersand string, right? And a reference is really just another value that can be passed around. And as we saw at the end, there are some values that are so cheap they can be copied. Well, a shared reference, like this one, or just a reference as I usually say, can be passed around. It's a copy type, right? So you can create as many copies as you like, and that's just fine. Okay, so that's the basic idea of borrowing, but I want to explore more deeply the matter of mutability. So you may recall I said that shared references, while the reference exists, the data has to be immutable, or at least is normally immutable, unless you have a lock or some other means to protect access, right? And you might have thought that means that the following code would not compile. So I've just modified to declare the variable name to be mutable, like we saw in the ownership tutorial, and I'm going to push a new letter on it, right? So when I run now, you might expect this not to compile, but it does. And you see we're now printing rustations X. The reason you might have expected it not to compile is I said that shared references are immutable, and yet this value is clearly mutable, right? And the catch is that the way Rust views mutability is it's a very time-based thing. Nothing is purely mutable or immutable. It's a question of when is it mutable. So here, the variable is declared as mutable, which means that it's basically mutable except when it's borrowed. So in this part of the code, it hasn't been borrowed yet, and therefore we can mutate it as much as we like. But here, a name was borrowed to create R, and that means that if we try to do a mutation while this variable R exists, we're going to get errors. Now we got an error, right? Because this, you see the error is right here on this line, and it's saying, you've already borrowed name here on the line above in order to make the reference. Now you can't go ahead and mutate it. And so that applies until the variable r goes out of scope, right? So it's just as true here. I'm going to get an error. And it's also true here after both of the helper calls have finished. Now, sometimes people find this a little surprising because they think, well, I'm done using the variable r. Why am I still prevented from modifying name? Isn't the borrow over? Well, the answer is that it's not, at least not the way the compiler works today. The borrow extends until that variable r actually goes out of scope, right? So if I, for example, create a new scope, so you can insert blocks wherever you like, right? And now this variable r, it's constrained to only be used inside this block. So I can't name r here. This would be an out-of-scope reference, right? This variable doesn't exist. But now the borrow will end here at the closing block, and hence I can run this code and it compiles just fine. So you see that now we have a variable that started mutable, got frozen, and then became sort of thawed and mutable again, just based on where when there were references that were existing. All right, let's go back to the slides and see a little bit more. So we're almost done here with the shared borrows, but I want to show you one really cool thing that follows from them in Rust. So in all the examples we've looked at, we've had a shared reference to an entire string buffer. But a lot of times you just want to process a subset of a string, like the first word or something like that. Right? And Rust makes that really easy and really efficient. And to see how it works, we have to dig a little bit deeper into what strings look like at runtime. So when I make a string buffer, like on this highlighted line of code, where I say let name equals format bang, it has this shape at runtime. A string buffer is really 3 bits of data. There's the data, which is a kind of reference to the buffer itself in memory, right? So in that case, it might have the word rustation in it. And then there's a length and a capacity. The length is the amount of data that we're actually using in our buffer, and the capacity is the total space available. Usually we have extra space, so that when we append things to the string, we have someplace to put them, right? And now, here I'm going to call helper, but you see that the helper function looks a little different. Instead of taking an ampersand string with a capital S, it takes an ampersand stir with a lowercase s. That's called a string slice. So the type stir in Rust means basically some subset of a string buffer, right? And that's always, or almost always, something you borrow from a string buffer, right? And on the other side, we didn't just write ampersand name, we wrote ampersand name, and we had these brackets and said from the character 1 on. So that means this is going to skip the first character in the string, actually the first byte. So in this case, when we're going to create a reference, what we wind up doing is we have a reference directly into the string buffer, just skipping over the first letter. What's really cool about this is that there's no allocation and no copying, right? We're just kind of keeping our finger into the data that is in the big string buffer, right? Just some subset of that data. And you see there's also a length. This tells us how many characters we have left. So the length of this substring would be 1 less than the length of the full string. And now this is just a borrowed reference like anything else. It's just instead of referring to the whole string buffer, it refers to a subset of its data. So we can call helper, and when helper's done, no memory is going to get freed. And you see that we can also pass helper the whole string, just like we did before, ampersand name, without any of that subsetting stuff. And it still works just fine because, of course, a subset of the whole string is also a subset of itself. Right. So this looks a lot like the syntax you might see in other languages. You see in the bottom, you can have Python has similar syntax and Ruby. But unlike those languages, we're not making a new string object and returning it. We're just having a kind of shared reference to a subset of the string's data. Now, this really scales up when you start building higher level abstractions that work over strings. Right, so here, for example, we see a snippet of code that iterates over a line and sums up the length of each word in the line. So it kind of skips whitespace. So this line.split, this is actually a method on strings, string slices actually, that returns an iterator that will yield up the whitespace separated, in this case, whitespace separated substrings. And so basically it's going to return an iterator over all the words. So if we have this as our line, which is the full string buffer, sing, goddess of Achilles' rage, black and murderous, then each time we pull something out of the iterator, we're going to get a new subslice. So first we'll get sing, then goddess, then of, and so forth, right? And because each of these can be constructed very cheaply, when the optimizer is finished with this loop, we're going to get something just like we would have written in C, which is basically a pointer pointing into this buffer of memory and bumping ahead by a couple bytes each time. Very cheap. Very different than if we had this kind of high-level code in some other language where you would actually have to allocate objects for the iterator, allocate objects for the slices of the strings that you're returning, and so forth. Right? So this is why Rust is able to have this high-level code with such low-level performance. That brings us to the end of our tutorial. So the last thing is left is the exercise. Now if you look down below this YouTube video, if you're on the website, or the URL that you see in the corner there, then you'll find the shared borrows exercise. So I want you to click on it, and we'll go over it real briefly, and you should do the goals, and then come back here for the solution. Okay, so here's the exercise. This is basically our traditional example of calling greet twice. And what we're going to do now, the first goal is to convert this function so that greet, instead of taking ownership of this string, borrows the string, and therefore we can remove this call to clone. Right? And if we just do that now, of course, we're going to get a compilation error because we're using the moved value twice. And the second goal, once you've done that, is to insert some sub-slicing so that we can print hello friend instead of hello my friend. All right, get to it. Do 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 do. You know, I'm gonna have to find a new song. This is getting kind of old. Okay, so this was the function we had to start, and if we run, we're gonna get compilation errors. We first want to change it to use borrowing. So in that case, we have to change, instead of taking ownership of a string, we take a shared reference. And similarly, we supply not the string itself, but a shared reference to the string. And now the code compiles. Now we wanted to use a subslice to skip the first few letters. So one way we could do that is to skip it right here at the point of printing. What is it? Oh, time. So there's this problem with the play server. I'm going to leave this in the screencast just because it's occasionally worth knowing about, where sometimes it'll time out because it would happen to be heavily in use at the time, and then it will cache that timeout. We should fix that bug. But one thing you can do is just modify your program in some way to bypass the cache. Anyway, here you see hello friend. So we skipped the first three letters. That's what we wanted to do, but it seems a little weird to have greet skipping the first three letters because that implies that there will always be, like for every name, the first three letters are not important, which of course may not be true. It would be better to skip the three letters here at the point where we call greet and say, in this particular case, I know that the first three letters are not good, but if we just do that, we're going to get an error, mismatch types, and the problem is the signature of name is still requesting a reference to a string buffer, and what we really want is just a reference to a subset of a string, str. Now if we do this, now we'll see hello friend the first time and hello my friend the second time. Okay, thank you very much for attending this shared borrows tutorial. I hope you will enjoy future tutorials. One that might be, so to directly carry on with this work, there's a tutorial on mutable borrowing that shows basically how you can make references like this, but you can actually mutate the thing they refer to instead of having immutable access. And then there are other tutorials covering other aspects of Rust. Thanks a lot.